Alright, in this video here we're going to talk about some of the properties of real numbers. So the first property of real numbers that we'll talk about is what we call the commutative property. Right? The commutative property basically says you can do things in either order and it doesn't really matter. Right? So the commutative property applies to addition and multiplication. Right? So A plus B equals B plus A. That's the commutative property of addition. Right? That's saying if I add two numbers together, which one I put first and which one I put second doesn't change the outcome or the sum of those two numbers. Right? Same for multiplication. A times B equals B times A. If I'm multiplying two numbers, which one I put first and which one I put second doesn't change the product, right? The outcome of the multiplication. Right? So for a couple of quick examples just to show you. Let's say I have 3 plus 5. Well, that's the same as 5 plus 3. Right? Either way, it equals 8. It doesn't matter if I do it as 3 plus 5 or 5 plus 3. Both add up to 8. That's what we mean by the commutative property. Right? Same for multiplication. If I do 3 times 5, that's the same as 5 times 3. Right? They both just equal 15. It doesn't matter which one I put first or second when I write that multiplication out. Right? So that's our commutative property for addition and for multiplication. But remember, it only applies to addition and multiplication. It does not apply to subtraction or to division. Right? If I do 3 minus 5, that is not the same as 5 minus 3. Right? 3 minus 5 is negative 2, 5 minus 3 is positive 2, right? Which gives you two completely different answers. Right? So the commutative property does not apply to subtraction. I can't just switch the order of the numbers in subtraction. I get a different result. Same for division. Right? If I do 3 divided by 5, that's not the same thing as 5 divided by 3. Right? This one gives me the fraction 3/5. This one gives me the fraction 5/3, which again are two completely different numbers. Right? So the commutative property, again, only applies to addition and multiplication, but when we're doing addition and multiplication, the order that we put the numbers together does not matter. Right? With subtraction and division, that order does matter, so make sure you pay attention to that. Right? It's one of those little details you have to be aware of. The next property we have, the associative property of real numbers, is when we're adding or multiplying more than two numbers, the way we associate them or how we put those numbers together doesn't matter. Right? So if I have like A plus B plus C, right, three numbers that I'm adding together. Well, if I add those first two numbers together first and then add the third to that, I get the same answer as if I add the second two numbers together and then add the first number to that sum. Right? Either way, it adds up the same. Same idea with multiplication. A times B times C equals A times B times C. Right? If I'm multiplying three numbers, which two I multiply together first doesn't matter. As long as I multiply all three, eventually I get the same result. All right, so an example of that, let's say we had 1 plus 2 plus 3, just to keep things really simple. All right, so if I add it like this, remember, when I have parentheses there, I have to do what's inside the parentheses first. That's my order of operations. Right? I do inside parentheses first. So 1 plus 2 is 3, and then 3 plus 3 equals 6. Right? If I had that same problem, 1 plus 2 plus 3, but I associate the last two first, right? The 2 plus 3, if I put that in parentheses and I add those together first, well, 2 plus 3 is 5. Right? So I get 1 plus 5, which still equals 6. Right? Either way I add those numbers together, I get 6. I could even add first the 1 plus 3 and get 4, and then add 4 plus 2 to also get 6. Right? So when I'm adding a group of numbers, more than just two numbers, the order that I combine them doesn't matter as long as I eventually add them all together. Right? And the same idea for multiplication. I won't waste your time doing another example of that. But multiplication is the same thing. If I have three numbers multiplied together, I can multiply the first times the second, get that answer, and then the third. Or I can multiply the second times the third, get that answer, and multiply it by the first. Right? If you don't believe me, just try it with three numbers. As long as you do your multiplication correctly, it's going to come out the same no matter which way you associate those numbers. All right, so that's what we call the associative property. And again, just like the commutative property up here, it only applies to addition and multiplication. Right? If I'm subtracting three numbers, if I try to subtract the second and the third number first, and then do the first one minus that answer, I get something different than if I do them in order. All right, so again, you can only use these associative and commutative properties if you're dealing with addition and multiplication. They don't apply for subtraction or division. All right, and what these properties are used for, they're used obviously when you're doing calculations, just like adding and multiplying numbers. Sometimes you use these properties when you're doing that just to like put them in order that makes it a little bit easier to add together. Like for example, if I had to do 8 plus 5 plus 2, well, let me add the 8 and the 2 first. That gives me 10, and then 10 plus 5 equals 15. Right? That might be easier to do than 8 plus 5 and then get that answer and add 2 to it. Either way, it comes out to 15. But sometimes you can combine the numbers together in ways that make it a little bit easier. These properties are also used in algebra when you're trying to simplify expressions, or you just need to like rearrange an expression to make it a little bit easier to work with. So sometimes you will call up the commutative and the associative properties in order to do things like that, just like for simplifying and that type of thing. And again, the key thing is you can only do this stuff if it's addition or multiplication. If you have subtraction or division, these properties don't apply. All right, so that's our first 2 properties of real numbers. I'm going to pause the video real quick to erase this stuff and then put up the third property of real numbers, which is really the most important one that's on here. All right, the next property we have up here is the distributive property. And out of these 3 properties of real numbers that we're talking about here, this is the one that we definitely use the most often, especially going into algebra and use it in precalculus and calculus as well. The distributive property comes up all the time. Right? We use it when we're trying to simplify expressions. We use it when we're trying to solve equations. It comes up a lot, so it's an important thing to understand and know how to do. Right? What the distributive property says is if I have something multiplied by a quantity in parentheses, right? So A times parentheses B plus C, right? What that's equal to is A times B plus A times C. Basically, whatever number or quantity or variable or whatever it is outside that parentheses, multiplying that parentheses, it multiplies everything that's inside that parentheses, right? So the A multiplies the B and the A multiplies the C. So it's A times B plus A times C. All right. Also, another way to write that, or another formulation of the distributive property, B plus C in parentheses times A also equals AB plus AC. Right? Normally we see the distributive property with the one quantity in front of the parentheses, but if we have a number or a variable at the end of a parentheses, like after the parentheses, the distributive property still holds there, because remember, we can use the commutative property, right? These 2 things are the same. B plus C times A is the same as A times B plus C. If I'm multiplying those 2 things, I can switch the order, just like we saw a few minutes ago with 3 times 5 and 5 times 3, right? The order that I put them doesn't matter. So whether that A is in front of the parentheses or behind the parentheses, it's still the distributive property and it still works, right? Normally we see it in front, but every once in a while you might see something hanging at the end of the parentheses. You can still distribute that into the parentheses, right? Remember that B plus C in parentheses, that means one whole quantity of something multiplied by that A, right? The parentheses is a grouping thing that we have in math that tells us this B plus C goes together and that whole quantity multiplies the A. Right, which is why I can switch the order of where that A is and still get the same result. All right, so an example of how you would use that when you're doing a calculation, and normally this is not how we use the distributive property, but just to show you what I've been talking about for the last minute or so. If I have 2 times parentheses 4 plus 5, there's 2 ways you can go about that. I can say, well, I have the 4 plus 5 in parentheses, so let me add those together first. That gives me 2 times 9, which equals 18. Right? Again, the 2 is multiplying that entire quantity that's inside the parentheses. Right? The 2 is not just multiplying the 4, it's multiplying that entire quantity of 4 plus 5, so the 2 is multiplying the 9. Right? Another way we could write that is saying, well, since the 2 is multiplying everything inside the parentheses, let me multiply the 2 times everything inside the parentheses. Right? 2 times 4 plus 2 times 5. Right? And I still have that plus there because that plus was in between the 4 and the 5 to begin with. So when I distribute that 2 into the parentheses, right, that plus still stays in between those 2 quantities. Right? So 2 times 4 is 8, plus 2 times 5 is 10, and 8 plus 10 equals 18. Right? So whichever way we do that, we get the same result. And normally, if I was like actually trying to solve a problem that looked like this, I would add the 4 plus 5 and get 9 and just multiply 2 times 9 and get 18. That's easier than actually using the distributive property to figure that out. So you might be thinking, well, then why do we have this distributive property if it actually makes doing that calculation a little bit more difficult to do? All right, the reason we have the distributive property is because, well, what if one of the quantities we have is a variable? Right? Instead of 2 times parentheses 4 plus 5, what if it's 2 times parentheses x plus 3? And I have to do something, I have to simplify this expression, or maybe that's part of a bigger equation that I need to solve. What do I do then? Well, I can't actually add x plus 3 like I did up here, 4 plus 5 to get 9. I don't know what x is, so I can't write anything for x plus 3. So what I do here to simplify this or to work on this expression is I distribute that 2. right? The 2 multiplies both of the things in the parentheses, so it's 2 times x plus 2 times 3, which equals 6. All right, so 2 times the quantity of x plus 3 equals 2x plus 6. Right, so when we have a variable thrown into the mix, right, we have to use the distributive property to work with that. Whereas up here, when everything was numbers, I had choices and I could pick one way or the other to figure it out. But with variables, the distributive property is what we need to do to simplify or to do some type of mathematical work on an expression that looks like this, which is why I said a couple minutes ago that distributive property is really the key one out of these properties of real numbers. It comes up all the time in algebra and higher levels of math as well. All right, the last example up here, negative of parentheses x plus y minus 3. Right, this is one of those things that I see students make mistakes on all the time. What a lot of students tend to do is like, oh, there's a negative here. That negative goes with the x and everything else just stays the same. That's not what it is, right? Remember, everything in this parentheses is grouped together. Anything that's happening outside that parentheses applies to the entire parentheses. Everything inside that group is getting that negative applied to it. Just like everything inside here, the x plus 3 was being multiplied by this 2, everything inside this parentheses has that negative applied to it. Or another way to think about it is that negative outside of the parentheses, think of that as a negative 1 multiplying x plus y minus 3. And that negative 1 gets distributed to everything inside that parentheses, not just the first thing you see. Right? Another key thing about this problem here is the distributive property applies no matter how many things you have inside your parentheses. Right up here it just has a b plus c, there's just 2 things there. Here the x plus 3, there were just 2 terms inside the parentheses. Now we have 3 terms inside the parentheses. You could have 3 terms, 2 terms, you could have 17 terms inside your parentheses. Whatever's on the outside gets distributed to everything that's in there, no matter how many there are. All right, so that negative or that negative 1 gets distributed to the x, so negative 1 times x is going to be negative x, negative 1 times y is going to be negative y, and then negative 1 times negative 3 is going to be a positive 3. Right, so negative of parentheses x plus y minus 3 actually equals negative x minus y plus 3. Right, notice what happened. When I have a negative outside that parentheses, the sign of everything inside got switched. Right, positive x became negative x, positive y became negative y, negative 3 became positive 3. Right, that's what happens when you distribute the negative or multiply the negative 1. Everything's sign gets switched. And that's something that comes up in some higher things in algebra that you'll see, problems where you have to combine things together. A lot of times you'll have a negative outside of parentheses. Like I said a minute ago, it's a real common mistake I see people make, not distribute that negative appropriately. Right? Remember, whatever's in parentheses, all that stuff is grouped together. Anything that's outside that parentheses applies to everything in that group. Right? It's the negative of all this stuff here. So every single one of those has to get that negative applied to it. Right? So it's a real common thing that people mess up on. But it's a simple thing. If you understand what that parentheses means, is that whole thing is grouped together, but there's no reason to make a mistake there. Right? Whatever's outside the parentheses, whether it's a 2 or a negative or whatever it is, gets distributed to everything inside. All right, so that's our properties of real numbers. We have the commutative, the associative property, the distributive property. I hope that all made sense.